Good. Perfect. Well, congratulations all of you for waking up. So we're going to talk about something completely different this morning, and then try and see how that completely different thing translates into your industry. So I'm going to talk about aviation security. We're going to talk about how does aviation security really actually work, what's really going on in the aviation security field. Then I want to talk about why is that relevant to the red meat industry, and then what are we doing here in Australia to support the red meat industry. So when you imagine that sequence of events as you plan a trip, you do all this work to kind of get yourself ready to go. Where do you want to go? When do you want to go? What airline do you want? What airports? And so on, so on, so on. You then eventually get to the departure airport. Then there's a whole sort of process of things that happens as you get into the terminals, you check in, drop your bags, as you go through the checkpoints, as your whole baggage screened, as you get to the gate. There's a lot of things going on in the background. So we can describe a lot of these activities in terms of basic processes that are going on. So at the beginning, you're all aware of selecting a flight, of booking, paying, all that kind of stuff. These are all processes that go on. And they go all the way through until you've got to the destination airport. And what I want to kind of plant in your mind is the idea that this is not that far different from some of the things that are much more familiar to you in the red meat industry. So you can say the final objective of a producer is to get an animal to an abattoir, right? So it's like arriving at an airport. And then the processor, as they take that animal, convert it to a carcass, package it up, their final objective is to ship that to a customer at a fair price, which is equivalent to boarding the flight. Then, you know, the next part, the consumer, through the supply chain, through the supermarkets and so on, will then package that meat, get it to the consumer, present it in a way the consumer feels excited by, so the consumer pays a good price for it, and that's the equivalent in my parlance of leaving the airport, okay? So I know it's a bit contrived, but I want you to understand that there's a good sort of rationale behind what we're doing. We're not just investing for fun. So in the aviation side, we always start with detection. If we can't find something, can't find a bad person, a bad threat, something that shouldn't be there, we're not going to be successful. To have high throughput, air passenger is growing, so we need to start automating processes. The way we used to do things in the past, where you'd have lots of people manning a lane, those kind of days are going. So to do that detection, putting automation around it is becoming increasingly important. Then there's a whole area of integration. How do you bring multiple sensors together so that we can present information to an inspector in a consistent way, in a location that is conducive to good detection and good inspection, rather than in a public area, maybe where there's lots of people rushing around and so on. So when you think about this, again, put your meat industry hats on. You've got MSA, is the equivalent detection, right? And then you want to try to get the carcasses through the factories. You want to grow them in the fields efficiently and so on. And that means integrating lots of information to bring it all together so that at the end of that, you get the best possible performance. So what happens underneath the covers? So underneath the covers, we have a whole bunch of technologies that you'll be familiar with seeing at the aviation checkpoint. So these machines, some of them you'll see at the checkpoint. So some of the smaller machines like these you'll see at aviation checkpoints, and other machines like these you will often see more in an air cargo or a baggage type area. And then you'll be familiar also with the metal detectors and the various different machines where you stand like this, which we call the surrender pose, or alternatively in the gunslinger pose. So you'll see these kind of things quite often as well. So these are all trying to find dielectric, so non-metallic threats like explosives, narcotics, and so on, or we're looking for metallic objects like knives, guns, ammunition, and so on. Inside those X-ray machines, we have two different configurations. One is what we call a single view, and the single view is quite closely related to the DEXA units, which are now being employed in meat industry. And the dual view systems we use to get a much more accurate measurement of the properties of the explosives. So we're interested in what we call the Z effective, the effective atomic number, which is all about the atomic composition. So the atomic composition of ammonium nitride or the atomic composition of Christmas pudding, two different things, right? So if we can understand the the atomic composition of things, we can do a better job of saying, this is benign, this is an explosive. If we have Z effective, this is one parameter. If we can get another parameter, like, for example, density, then we have two different things that we can explore. So we can then put up images where we color code the images based on material property. So this is the kind of thing you're used to seeing on the screen at an airport. Well, maybe something more like this. So this blue thing here, I can tell you is metal because the Z effective is greater than 18, right? This material down here, I could be pretty confident is aluminium because the green color indicates a Z effective or an effective atomic number, some in the region of sort of 12 to 16, something like that. So, and then the brown regions here are what we call organics. So an inspector would be particularly interested in something like that, a large, dense organic mass that could well be an explosive, okay? So this is what the operator is looking for when you see them at the airport inspecting images. So we use color coding, then we measure image quality in terms of penetration. So this is a penetration test object, grid resolution, wire resolution, and its ability to resolve, sugar from salt, this kind of thing, okay? If we go to a single view system, like a single view DEXA system, we effectively get this plot here where we have one parameter, which is the Z effective from the dual energy part. These green dots are indicating benign materials, and the red dots are indicating explosive materials. So you can see in this single view system, we've got a lot of overlapping of the red and the green dots, and our inspection accuracy is related to this blue disk over here. So you can see within our measurement, we could have had a number of different explosives and a number of different possible benign objects, so it becomes really difficult to determine whether this bag is a threat. If we go to a dual view system, which we see on the right-hand side here, we're measuring density across the bottom, Z effective across the top, the red things, explosives, green things, not explosives. You can now see that by stretching out into the two axes, we can do a much better job of resolving explosives from benign objects. So the thinking is, if we take the same kind of technologies, extending it from two views to multi-views, going to true three-dimensional imaging, where we can get density and Z effective on a per voxel basis in 3D, we now have the information necessary to do a very good job at detecting bombs, but also a very good job of detecting intramuscular fat, right? So that's basically where we're trying to get to with all of this. Automation in airports, you're maybe starting to get used to seeing systems like this, where we have a passenger arriving in here, we feed them with trays, they put their stuff in trays, go through the X-ray machine, then we can decide to divert across into a reject channel or allow that tray to move forward to the passenger. So this sort of thing is becoming more and more common now, and we have different things where we have what we call parallel load. So now we can have multiple passengers divesting simultaneously over to the reclaim area. So although the automation in the airports, I think, has a tremendously long way still to go, I think it's terrible at the moment, okay? So we're innovating a lot in how we can do better automation in the airports, and I know that in the red meat industry, there's a huge amount of work going on in terms of automation to improve processes in red meat industry as well. So I'm just trying to highlight some of the parallels between the two industries. Integration is really important. We start with an operating system. We add an integration layer so we can bring different sensors together. We provide applications over the top that allow you to use that information for something helpful. We ring fence all that with a strong cybersecurity level, because without that you can't connect everything together. Then we bring peripheral devices. In our case, it could be a biometric reader. In your case, it could be an AirTag reader for an animal. Users. We have different people wanting to see different things. So a security director, an administrator, a finance director, a chief executive, they all want to see different things from that data, which means we need to provide networks and storage so we can manage and move that data around. Open standards, really, really important. We're driving the whole open standards thing in the security space, and I really encourage you in the red meat industry to really concentrate on open standards, because with that you can have great growth. Common image views, doesn't matter where the data comes from, we should be able to put it up in ways that we can look at the image consistently. And management dashboards, as you all know, are very, very important for helping to understand the whole process. So we're building this large integration platform for the security side, and it really maps directly back across to the red meat side if we choose to do that. So I apologize, it's a bit of a complex slide. But when we look at the entities that are entering the airport, it's not just the passenger, but it's also their carry-on baggage. It's also their hold baggage, so the baggage that you check, where you put the little tag and it goes into the whole baggage system, and also other external data. So if we just pause on this for a minute, the whole point for a passenger is, first of all, to divest. So take your jacket off. If you go to the US, you have to take your shoes off. You have to take certain things out of your pocket. Sometimes you have to take your belt off. It's very confusing as a passenger to know in a different airport what you're supposed to be doing. So I was going through a New Zealand airport the other day, and the ConOps was completely different to an Australian airport. I mean, why is that? So divesting, then screening. Again, we have different methods for screening. We have millimeter wave, we have terahertz, we have metal detection, we have ultra-wideband, lots of different technologies that we use for people screening. And out of all of those different methods, you get detection. So detection in metal detection, detection in millimeter wave is quite a different phenomenon or philosophy that we're using to detect. But ultimately, what we're attempting to do is to clear the passenger. We want to say, yeah, you're safe to travel. So we do all this prior work, some of it unseen to the passenger, and others of it is very explicit to the passenger, to try to figure out how to clear them. And out of all of that, we get something called an Object of Inspection Threat Detection Report. So I apologize for the mouthful and the acronyms, but our industry is really good at unpronounceable three-letter acronyms. So these threat detection reports describe just that passenger. It says, we found a non-metallic threat in the person's pocket. We cleared it because it turned out to be a handkerchief, right? So the threat detection report contains that language. Then we need to look at the carry-on bags that belong to that passenger. So again, we may ask the passenger to divest a laptop, maybe liquids, maybe other things as well. We then screen generally with X-rays, so we can then run a detection process so that we can then clear that bag. If we can't clear that bag, you go to the naughty boy lane, they search your bag, they extract whatever it was they're not happy with, and eventually they clear you to travel. And again, we now create a threat detection report related just to your carry-on bag, one threat detection report for each tray or each bag that you have. Then your whole baggage, we don't divest, but it goes straight to screening. And in whole baggage systems, we run an automatic detection algorithm called an explosives detection system algorithm. We run that directly on your bag. If we, in the machine, determine that your bag is safe, we clear it, and it goes straight to the aircraft. If we raise an alarm, we then send an image to an operator to try to clear that alarm. If they can't clear the alarm, we then take it again to an explosives room, and we try to do a physical search on your bag. Okay. So again, we attempt to clear your bags and again create a threat detection report. And then we have a bunch of external data that comes into the process. So that could be data from the airlines, could be data from the risk assessing agencies, whether it's the Drug Enforcement Agency, whether it's the Home Affairs, doesn't matter. Many different agencies have information about passengers. And all of that builds up into government-held risk data. So that allows us to pass a single piece of information like an IATA tag, an International Airline Transport Association tag number, which is the number that gets printed on your boarding card. We can pass that information, get information back about your risk profile as an individual, and use that to tailor the screening process. So, all of these threat detection reports are then combined together with the external data to make a final threat decision, what we call an aggregate threat detection report. So just change thinking for a minute from threat detection report to animal lifetime record. Okay, and now you can start to see how we can use all the same things. What was happening in the field, what was happening in the abattoir, what was happening in the distribution chain, what was happening in the supermarkets, build up those, not threat detection reports, but animal lifetime reports. And those together give you, in summary, a complete view of that animal's path from conception to the consumer. So we generally have this kind of loop of things that are going on around. So how do we do security performance monitoring? There's no good having a security system if you can't audit it, if you can't monitor it and maintain it. How do we link imaging systems or security systems to other things? How do we deal with passenger experience? Because as a customer in the airport, you never want to have that delay at security. So the other day I was going through an airport and there's a 100-yard queue to get through security. And I'm really frustrated, because why is there a 100-yard queue? There doesn't need to be one. But there is one, right? So you have to deal with it. But the question is, as an industry, how can we deal with that queue management? And then, remote system monitoring is also very important in these systems, so you can monitor the systems and deal with them remotely, whether it's from a field service point of view, an operational point of view, changing risk profiles on the fly, and so on. So I think you can, as you look at this, you can start to see parallels to your industry if you go into the right mindset. So what's going on in the world of aviation security? So there's a new US Transportation Security Administration requirement. Where the US wants to go is to recognize that 90% of its cost is running people and 10% of its cost is actually doing its job in terms of equipment and facilities. So that the US is saying, how do we take that 90% of our operational cost and reduce that? And a good way of doing that is to simplify the aviation checkpoint, which is where a lot of their money is spent. So the US is moving to a new regulatory framework to scan cabin baggage for all types of threats, so explosive threats, weapons, guns, ammunition, and a range of other things that we don't need to talk about. Doing all that automatically without an inspector actually looking at the image itself. If we then automatically detect something in a machine, we send the image to the operator and the passenger will be queried. So the idea is that every passenger that raised an alarm will get stopped, and that will soon train people to not put bad stuff in their bags, because getting stopped is going to be frustrating. So this is a new process. It's in conception at the moment in the US. The regulatory standards are being defined. I think over the next 3 to 5 years that will become really the situation in the US. In the EU, the plan is to try to leave liquids and laptops in the bags by putting more comprehensive screening methods together. Australia has adopted the EU model but is leading. So by 2022, all airports in Australia will have to have true three-dimensional imaging at the checkpoint, so you don't remove anything from your bag. Okay? And the reason for that is there's 1 or 2 threats have actually come from Australia recently onto international flights. So there's been more naughty things found coming from Australia than most other countries just over the last 2 years, surprisingly. Okay? So that's why the Australian government have invested, I think, 230 million Aussie dollars over the next 5 years to address that problem. So Australia has gone from being, dare I say it, not terribly avant-garde to leading edge in aviation security over the last 3 months. Okay? I don't want to say that MLA is responsible for that, but I think the MLA approach to three-dimensional imaging with us has raised a lot of awareness of three-dimensional imaging in Australia. And certainly aviation security is massively aware of what we're doing in MLA, and I'll talk about a little bit of that in a minute. There's other things going on. I think you're all familiar with DEXA. So we're now moving to what we call MEXA, multi-energy X-ray analysis. Multi-energy sensing is really it's really challenging from an intellectual point of view. I mean, it's a lot of fun to work on this stuff. So we're doing all sorts of semiconductor work, all sorts of really high complexity electronics, full custom integrated circuit designs to make little things that look like this, which is really innocuous, but it's an X-ray spectrum. And from that X-ray spectrum, we can now start to really understand the properties of the materials in much more detail than if we just have an overlapping dual energy measurement. So this is a huge area of investment for us. But a lot of this investment is being conducted under a program that we're doing with Meat and Livestock Australia. This is another machine. This first unit of this type has been now installed in Avalon Airport outside of Melbourne. So Melbourne is taking the lead in this whole area at this particular time. So this is a rotating gantry CT, and we've scanned quite a lot of beef primals and lamb carcasses through this particular machine. So we established a program which I'll explain in more detail in a minute with Meat and Livestock Australia. Meat and Livestock Australia has got a good profile, as you're aware, in the regional economy down here. So the Department for Agriculture in Australia got wind of what we were doing with Meat and Livestock, and figured that if Meat and Livestock Australia can start to move towards three-dimensional imaging, multi-energy imaging, and all this really cool, difficult stuff, then why on earth can't biosecurity? So the biosecurity team is led by a really forward-looking lady, Jessica Mitchell, and she absolutely took the opinion, if MLA can do this, so can I. So she was telling me yesterday that she put together a budget for 4-year program in biosecurity for Australia, which used to have a budget this big. She put forward a budget of $75 million to the feds, and they came back with $7.5 million. She was really shocked and really delighted. So we're helping her, of course, to spend a little bit of that money. So we've now, and Jessica has brought together the biosecurity team in Australia and also the equivalent biosecurity team in MPI in New Zealand. So under a bilateral trans-Tasman data sharing agreement, you may have seen the announcements from the minister over the last few weeks. In Australia, we've now put a machine that's now on the concourse, the International Arrivals Concourse in Melbourne. We've got another RTT-110 machine in the International Arrivals area in Auckland Airport. And those 2 machines are now being used to scan very large numbers of incoming passengers every day coming into Melbourne and Auckland. We take all the data, we stick it up into Amazon Web Services, so we're running a true cloud computing environment for this live airport data. We've employed an engineering team now in an office in Sydney, and we're working now on a biosecurity detection package. So apples, oranges, bananas, fruit, fish, meat, veg, plants, seeds, walking boots, tent poles, goodness knows what, loads and loads of stuff, right? Specifically to try to protect the borders of Australia and New Zealand to reduce the risk of biosecurity threat, which I think in your industry is massively important. So if you get a virus coming in, a foot and mouth or something, imagine what effect that would have in your industry. So there's a hugely closely linked program to everything we're doing with MLA. So I just want you to know and understand that we're investing not just in airport security, but with MLA and with the biosecurity program, because I think it all is so closely related. So now let me talk a bit more specifically about what we're doing with Meat and Livestock Australia. So we put up this funny little diagram at the beginning of the talk. And we said that there's a kind of a relationship between what's going on in red meat industry with what we're doing in the aviation side. And let me just try and put a little bit more kind of substance to that discussion. So I apologize, a lot of this is processor-centric, not producer-centric, because that's just where we are in our program at the moment. But the next phases of this program will move much more towards the producer. So you can understand much better than I can about all the work down here that's done in farm, feed, and veterinary practices, which is kind of analogous, if you like, to planning or booking a trip. There's tons and tons of work you will do, and I don't mean to trivialize any of the work you will do, but just bear with me. And the ultimate goal of the producer is to get animals to feedlot in a way that will maximize their value and cost them as little as possible to develop in the first place. Once they get to the processor, there's generally a period of feedlot optimization before the animal's taken to the slaughter room. And then there is a set of objective measurements, which is really similar to the security checkpoint. So if you think about the security checkpoint in aviation, it's really establishing that point from which you were an unsafe member of the public to where you're now a qualified traveler. Okay? There's that kind of that one point, the security checkpoint that really does that. And the objective measures, you can argue, is exactly that same point in the red meat industry. So the point of the producer is to get the highest yield, the highest meat quality, the lowest reject rate because of animal health or other issues, so that they can maximize the volume, maximize the value of that individual carcass. The objective measurements then allow the processor to determine the right pathway for that animal through the rest of the deboning process. So how are we going to segment that animal? How are we going to satisfy our consumers by supplying the right quality of meat with the right fat content, with the right fat layers in the right packaging? So those objective measurements and the 3D imaging that go with it are that kind of key differentiating point, if you like, from where the producer finishes to where the processor starts in my kind of naive mind. Okay? So having taken those objective measurements, you're then able to plan what you'd do in the boning room the next day or the next 2 days before you get to the final processing, which is how you then package the meat into your order book, if you like, from the consumers. Then, of course, in the consumers, it's all about distribution and display. How do you make nice-looking product that consumers want to buy at the highest possible price with minimum distribution costs, minimum lead times, etc. And then, of course, once the consumer takes that package of meat home, you want to get the very best feedback from them so they come back and buy more. So there's a lot of links, in my opinion, between these different things. And just as we have in aviation, I think you've heard a lot about this whole topic of data analytics over the last few days, but it's absolutely essential to link what the consumer is demanding at the back end with what the processor is doing, what the producer is doing right at the very front end. So all the way through this link, there's this requirement for what we think about as the animal lifetime record to continue to grow, develop, and build over the lifetime of the animal and over the lifetime of the farm. Because a farm is there to produce multiple animals over multiple years, and so it's aggregating all of that information together over long periods of time that really lead to transformative change in the industry and to the individual producer and the individual processor. So I hope that this kind of cheesy overview helps to explain why we're working in this field. So what are we doing with meat and livestock? So for whatever reason, I must have had a bit of a fit to the head or something, because when Sean said, hey, let's do this project together, we came up with a thing, and it ended up by being one of the largest programs I think MLA has ever undertaken with a single entity. So to put it in context, we now have 50 people working full-time around the globe in Southern California, Northern California, UK. We're now putting a team in Singapore, a team in Sydney, a team in India. And yeah, so I have plenty of air miles just visiting my own team, really. But 50 people, we're spending a bucket load of money every year. And what we're doing is developing products that suit the aviation industry and suit the red meat industry with slightly different optimizations in the two. So our thinking is we should be at the bottom of this pyramid thinking about things that are 2 to 4 years away from activity. So you can see, I don't know if you can read these small words, but automation. Unless we are really linked into the automation side, with the three-dimensional information that we're generating, that's a really key program for us. Another very key program is in meat science. Unless we really understand the meat science and how that meat science is driven by the image data that we can create, we're going to miss a trick. Similarly, animal health. If we can help to improve the genetic profile of the herds by providing really high-quality data back to the producers, then we can have, I think, some impact in animal health. Big data and big data analytics, you all know it's just a key to this whole industry. And machine learning, the ability to look at large volumes of data using automated processes is going to become more and more important. So these are our fundamental kind of areas of approach at the bottom. How do we deliver this? Well, we talk about image-driven process optimization. So we're an imaging company. The image is used intensively to drive the way that we do things. So that image-driven process optimization also leads to animal health genetic improvement because the two things are very closely related, and then those link directly back into customer satisfaction. So you can see that these 5 key things at the bottom there drive these 3 key things in the middle, but why are we really doing this? That's right, it's return on producer investment. Because unless you're going to make money out of this, what's the point? Right? There is no point. We wouldn't have a market, you wouldn't have any benefit to your industry. So at the end, we have to create return on investment, but that shouldn't be an infinite distance in the future. We're looking at 2 years from program start. We're about 9 months of real activity into this program now. So within the next year to 2 years, we would like to see real producers making real money on the basis of investment in this technology that we're doing together with MLA. So I hope that makes sense as a sort of overall structure. When we do these very difficult, complicated science and technology programs, which is where we are today, we're doing really leading-edge science and technology work. That drives into process trials and automation. So as we continue to optimize our processes, as we continue to support the automation programs by doing these underlying science and technology programs, the idea is that should start to have an impact on profit and on quality. If we can then make this a continuous loop, so all the time we're continuing to invest the science and technology side to continue to improve the impact on profit and quality by getting your feedback into this program all the way through. That's why we believe that this is something that can make a big difference to the industry. So the reason we're here talking in month 8 of this program, not in year 3 of this program, is because we need your feedback right from now to start to make sure that we're not doing something stupid. So with Meat and Livestock Australia, we are committed to deliver 3 machines. The first machine is already delivered, so there are now 3 RTT 110s in Australia. That's 3 more whole baggage screening certified bits of equipment than any other company has in Australia at this time. So we are the only company with full EU and US government approved whole baggage screening equipment. Now, of course, we're using it to scan cattle and sheep, but that's another whole story. So that's in country. It's in Melbourne. It happens to be sitting in a shed with Scott Automation at this time while we wait for a program to get started with the abattoirs. The next unit that will come down here is the 6040 dual view. So this has a 60 centimeter by 40 centimeter, 60 centimeter wide by 40 centimeter tall inspection tunnel. It's a multi-energy system, dual view, multi-energy. So we will get this unit down here probably about March time next year in 2019, and that will start to run a whole bunch of trial work in collaboration with Murdoch University. And then the machine on the right is the next generation 3-dimensional multi-energy CT, which I think will be a really transformative machine. So, and that will be down here at the end of 2019. So these are programs that are relatively close in the grand scheme of things. So we now have a team in Sydney that's really working on the meat industry objective measurement package in partnership with Graham Gardner and his team from Murdoch University. So I think we know absolutely nothing about meat science, so it's really important for us to work with experts who really do know a lot about this, so that we can concentrate on the technology while our colleagues concentrate on the science side relevant to your industry. So as I say, this unit has been installed recently. We are under the Meat and Livestock Australia program. We are rebuilding this machine almost from the ground up. It's about the only thing that will stay is the outside covers. And inside, we're changing almost everything to be a red meat industry specific machine as opposed to an aviation machine. So doing a lot of work on the X-ray detectors, a lot of work on the data acquisition, image reconstruction, and also the imaging workstations, because the requirements that you have to look at the data is very different to the requirements that we have in the airports. So again, working with Murdoch University, we're starting to collect quite a bit of image data with this machine. This is the new dual view, as I say. So this will be down here shortly, early in 2019. You'll notice that we put roller beds in here rather than the standard conveyors, so that when we do scanning, we can put the carcass or the primal into a plastic tub, scan the plastic tub through the machine on the rollers, keeps the machine nice and clean, so that we can then just clean the tub after the event, ready for the next scan. And this is the new multi-energy CT. This is a really complex machine. This is absolutely at the state of the art. When Transportation Security Administration discovered what we're doing with Meat and Livestock Australia, Transportation Security Administration gave us another very large grant on the back of the MLA program to deliver this new technology, which we're delivering for MLA into the aviation checkpoints in the US. So you will be responsible for the whole new security environment in the US if you're not careful. So don't blame me. It was all your fault. Right? So we've got a very large program, very strategic program between Rapiscan and MLA. We really are looking to deliver very high quality objective measurement in a very kind of methodical fashion to the red meat industry here in Australia, and I suspect overseas as well. It really does draw on a lot of our experience in developing X-ray systems and imaging systems and integration systems and stuff in the aviation security, but mapping this to the aviation into the red meat sector. You'll notice that the machines look like aviation machines. So a next stage in the program with MLA will be to start to make these food safe equipment, and that's another program that we're already discussing with MLA. We put a new R&D center in Sydney. We expect that R&D center to grow, so we're investing in the region in terms of intellectual activity as well. And I think you will feel good impact of this program within 2 years of program start. So with that, I'd be more than happy to take questions.
Thank you, Ed.
Great. Thanks, Sean.
So a couple of things that Ed didn't disclose, but I think we should. So that program that Ed's working now that he's just mentioned, so Ed's company's investing $11 million of their own money. So that's the investment that this company's making. And Ed, over the last 3 or 4 months, has given me snippets of the next big investment they want to make for our industry. So I think, you know, a couple of takeaways for this presentation for me is we need to keep looking at supply companies who are not only in our industry already, but in other industries as well. So imagine if we wanted this technology, but we were starting from scratch. It'd be a lot more than an $11 million investment. So Ed, I can't thank you enough for, I guess, the risk you've taken in us as an industry. And it's good to know that we'll make flying safer and better for all of our consumers as well, which I think is really important. So just want to thank you for that. So, and we'll have you out in Australia more often than not for these sorts of gigs. So just in the interest of time, if you've got any questions, put them into that slider and we'll get Ed to give us some feedback, and we'll cut that into the YouTube videos that we develop. So Ed, thank you very much. Thank you.